Okay, welcome. We're going to continue on here, and we're into chapter 2, which is sort of pretty much the heart of where we're going to start. Again, we did do chapter 1 as well last time, and as I mentioned last time, there's some math reviews and calculations, calculator type review. So make sure you do go over it. Again, the main two things really you're responsible for out of chapter 1, scientific scientific notation. That was in chapter 1, actually. So scientific notation and scientific method, I think, are the two things there. Again, obviously, at some point you need to know how to do the math that's in there and use your calculator and stuff like that. So again, it's a good little reference chapter on some of those things that you might need to do. So we got into chapter 2 last time, and we were talking about really measurements, and we talked about units as well. And as we talked about, it's really important to always, when you take a measurement, have a number and a unit associated with it. As we talked about last time, just a number by itself is essentially kind of useless in the sense that you have no frame of reference for what that number represents, what sort of scale you're talking about. So you should always be in the habit, as we talked about, when you do any type of measurement, you should always have that number and that unit. Remember, there's really two types of units that we talked about. There's the US sort of units, or the English units they're sometimes referred to, that we commonly use here in the US. Then again, pretty much everybody else kind of uses the metric system. So they kind of combine both of those, as we talked about last time, in the 60s, with what is sometimes referred to as the SI unit. And that SI unit is the International System of Units. It's again sort of a standardized unit that's used in chemistry and in science as well. And for the most part, it's very similar to the metric system in a sense. So it'll be very similar to that as well. The other important thing we talked about in terms of units is understanding what they actually mean or represent. So again, when we talk about a volume, that is something, for example, like a milliliter, a liter, or even a cubic centimeter, all represents different sort of units of volume. When we talk about a mass, kilogram, grams are very common units of mass. When we talk about sort of length, meters, centimeters, millimeters, these are again common sort of units of length that we come across. Temperature, as we talked about, there's a few different types, but Kelvin, for example, is a very common one that we come across here in chemistry. Remember, that is abbreviated with a capital K. And we also have degrees Celsius and degrees Fahrenheit. We do a lot of measurements and taking measurements using degrees Celsius, but we also do a lot of conversion from Celsius to Kelvin via this conversion here, where you take your temperature in Celsius and you basically add 273. So a lot of times in chemistry, the temperature does need to be in Kelvin to go into an actual equation or formula. But a lot of times, if you're actually taking the temperature measurement, it will be in Celsius. So that kind of Celsius to Kelvin is a very common conversion. Not too much Fahrenheit really pops in all that much here in chemistry, but it does occasionally. But I say Celsius a lot, and Celsius to Kelvin, and Kelvin back to Celsius. And again, if you had to go backwards and you wanted temperature in Celsius, that would be temperature in Kelvin minus 273. So both ways are very common. Out of the two, this one probably the one that you'll use the most. And as we'll talk about when we get there as well, and we might have last time, the true number is actually 273.15. Most people do round off the 0.15 there, and I'm good with using 273. But if you do see 273.15, that is really the right number that most people, again, usually will round off that last part anyways. More importantly, we talked about at the end was to how to properly take a measurement. And remember that anytime you do take a measurement, there is always going to be some degree of uncertainty. So there's always going to be some degree of, I'm not sure, some degree of estimation, guessing, if you will, uncertainty in your measurement. And the degree of that sort of guessing, if you will, or estimation, I guess is a better way of saying that, really depends on the piece of equipment that you're using. So whenever you're using any type of piece of equipment and you want to take a measurement, there's really kind of two things that you should look at. I refer to them usually as the large markings on the scale of the equipment. And the large markings are pretty much what it sounds like. They are the larger markings, and they usually are the ones that have numbers associated with it. The roll sheet's coming down, and it's actually coming down this time, not up. So it's coming down. Yeah, so it started on the top, coming down. So there you go. All right. So the large markings will actually usually have numbers associated with them. And there's also small markings, which do not usually have numbers associated with them on the scale. They are found between those large markings. So anywhere there's a large marking that does have numbers, the small markings are between them. So for example, we looked at a ruler last time, like we had something like this. And again, let's just say this ruler is in centimeters. So when we look at this, and if we're going to measure, we're looking at some arrows. So we'll go with an arrow right about there. So if we were going to try to take a proper measurement here, the first thing we really want to determine is, what does the large markings represent? And again, like I said, those are typically the ones that actually do have numbers associated with it. The difference between two large markings in a row, in this particular case, we have 1 centimeter, 2 centimeters. So once again, that is going to be a 1 centimeter difference. Obviously, if I kept drawing my ruler, we'd have 3, 4, 5, 6, and so forth, keep going down the road there. Now, when we are counting our small markings, it's important to make sure that you do count them correctly. So when you're going to count how many small markings there are between the large markings, you will always start after the previous last marking. So right there is where we would actually start counting our smaller markings. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. We stop counting the smaller markings once we hit the next large marking. So you always start counting the small markings past the first large marking and go to the next large marking. So what we really have here in this case, as we saw last time, was we have 10 little markings that represent basically 1 centimeter. So if you're not sure, you can just simply take the large marking divided by 10. And what that will tell you is each of the small markings in this particular scale, as we saw last time, represents 0.1 centimeters. So if we were going here and actually putting numbers, this guy again would be 1.1, 1.2, 1.3, 1.4, 1.5, 1.6, 1.7, 1.8, 1.9, and then off to 2 there at the end. And now that we really understand sort of what does each marking represent, it allows us to take a proper reading. And the first thing that we want to do is basically record any numbers that pretty much, no matter who looks at it, who looks at this markings, everybody should agree. So clearly in this case, everybody should agree my arrow there, which is, about to here, is at least 1.4. And because everybody should agree that, those numbers should definitely be recorded. These are what are sometimes referred to as all the certain numbers. Now, again, as we talked about last time, we could again clearly see that it's not exactly 1.4. Again, not exactly 1.5. We're somewhere between the two. And this is really where our uncertainty in our measurement is going to come into play. It is where really the estimation is going to come into play. And again, I may look at it and just see that to me, it looks maybe like it's halfway between those two marks. And I may record a 5 along with always the units, which would be centimeters in this case. And this is what is commonly referred to as the first uncertain number. Or sometimes people refer to this as the estimated digit or estimation type digit. And whenever you take a proper measurement, you should always record all the certain numbers, whatever numbers are certain, and that very first uncertain number where there is some type of estimation that's going to happen. And as we talked about last time, that's basically what makes up significant figures. And that would tell us that in this particular measurement, as we talked about last time, we would have actually 3 significant figures in this number, where the estimated digit there is going to be the 5. In most cases, people assume that it's kind of like plus or minus 1 of that last digit, kind of like a plus or minus 1. And really what that means is I think it's 1.45, but I may be wrong. It may be like 1.44, maybe 1.46. It's somewhere in that neighborhood. And that's really where the uncertainty lies. As we did a number of examples, I think last time, in general, in terms of rules of how far you should take your sort of measurement to, you typically could go one more place to the right of the smallest marking. So in this particular case here, our smallest marking went to the first decimal place. We were actually able to go one more place to the right of that first decimal place and actually take a reading. You can also, as we talked about, I think last time as well, if you are perhaps sure of what the smallest markings represent, but maybe you're still unsure as how far you should take the reading, all you have to do is, if you're for sure on the smallest markings, just take the smallest markings and divide it by 2, and that'll give you like plus or minus 0.05 centimeters. And that's basically 2 decimal places. And what that will tell you basically is how far you should take the reading to. So that'll give you kind of the uncertainty in that particular equipment. So there's some, speaking of uncertainty in your thought how far you should take the reading. You are fairly certain on small markings what they represent. Simply just divide it by 2. However far that number goes to is how far you should take the reading to on that particular scale. If it goes to 1 decimal place, then you should take it to 1 decimal place. If it goes to the whole number, I did one there last time. We go to the whole number, you should take it to the whole number and stuff like that. So that is the proper way to take a reading or a measurement. We also talked about that if it happens to be right on the nose, also really important. We'll extend my arrow right here to this line. Now, for example, if it was right on that line right there at the 1.5 marking, we would want to record 1.5. And in this case, because of the scaling there, we would have to include the 0 here to give a proper measurement. 1.5 would be our certain numbers. And this would be our first uncertain number in this particular case. By the way, that would have how many significant figures? 1.50 would have? It would have 3 significant figures in this case. And we have to do that because, as we talked about, I think at the very end last time, if you just wrote 1.5 centimeters, now what that has is only 2 significant figures. And really what you're saying in this case is, I'm not sure about the 5. And basically what you're saying is, I think it's 1.5, but maybe it's 1.6 or 1.4. And as I did last time, that is a whole bunch of error or uncertainty in there that you really shouldn't have based on the particular scale that we're using here. You should be able to do a lot better than that. And that's why we wouldn't want to do that. We would want to do this, because with that, again, it's saying I have 1.50, maybe it's 1.51 or 1.49. And that's basically right about there, which is proper based on this scale in terms of the error you should have. So by dropping that 0, for example, you're introducing a lot more error into your measurement, and you're making it a lot worse measurement than you should have done. And we talked about the other extreme as well, which is adding zeros, right? You don't want to add more zeros because that's making your measurement better than it should be based on the scale. So it's proper to figure out how far you can take the reading to. Any questions on measurements or how to take measurements or what we talked about last time? So I remind you that you should always, again, look at the scale that you're using, the piece of equipment that you're using. because it won't always be the same. So even again, like I said, in the lab, sometimes you and the person next to you may be using the same, say, 10 milliliter graduated cylinder, but the markings may always kind of look at them. They may be made by somebody else. All right, then if there are no questions on measurements, let us continue on. Since we just talked about measurements, let's do a little more examples here. So obviously here, if we look at this particular scale, we want to again think about our large markings here, right? And in this case, my large markings represent how much? How many centimeters? 1 centimeter, right? Again, you can look here, 4 to 5 is 1 centimeter, right? How about my small markings in this case? What do they represent? Are there small markings? The answer is there actually are small markings. They're the same as the large markings. They're the only markings here. So in this particular case, the small markings and the large markings are actually the same because there's no other markings present. So both the large and the small markings will be the same here. So when we look at this, it's at least 4, right? So we want our certain number. So it's at least 4. And again, we have our estimate here. So maybe you feel it's halfway there between those two, and you put your 5 and centimeters. This number here would have how many significant figures? Would have 2. The uncertain number would be is the 5. And again, we're saying I think it's 4.5, but maybe it's 4.6 on the high end. Maybe it's like 4.4. And again, that's reasonable because that's somewhere in that area-ish as to where we're guessing. Now, in this particular case, you could do the same thing that we just talked about, which is if you're sure about the small marking, you could just take the small marking, divide it by 2, and that gives you 0.5 centimeters. And really the 0.5 and all that doesn't matter, but what matters is that's 1 decimal place, and that is exactly where we should have took the reading to properly, to 1 decimal place. So again, that's what I mean when you can divide it by 2, the small marking, and it'll tell you how far you should take the reading to. So obviously 4.5. Now on this particular one here, we again could look at our scaling. We have the 4 and the 5. Once again, this is going to be a large marking of 1 centimeter. We're going to start counting our small markings between them. And in this case, we got 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 markings. So we have 10 markings between them. Again, we want to start past the last large marking, which was 4, and we want to stop at the next large marking, which in this case is 5. That's going to give us our certain numbers. If we don't blink the screen, it'll give us our certain numbers there. There we go. If we look at it, is at least 1, 2, 3, 4, and 5. So that is going to be our certain numbers there. Once again, this is where the estimate comes into play. We're between basically the 4.5 mark and the 4.6 mark. So they went with just halfway between there and gives us 4.55 centimeters. Our small markings, again here, since we had 10 of them, each of them is 0.1 centimeters divided by 10. Divide that by 2, gives you 0.05 centimeters plus or minus. That is 2 decimal places. That is 2 decimal places where we should take our reading to. Once again, usually one more place to the right of the smallest marking is where you should take that reading. This also would have 3 significant figures, with the last 5 there being the uncertain number. Question on that one there. All right, so this right here is one like we talked about. Once again, if we look at this scale, we have the same situation. We have our large markings being 1 centimeter. There's really no small markings, so that means that the small markings are going to be the same 1 centimeter. And once again here, we're exactly at 3. So if you record 3, I am not sure how far I should take it, so maybe I should just divide that by 2. And that tells me plus or minus 0.5 centimeters. When I divide 1 by 2, it gets me 0.5. That is 1 decimal place, which means here I do need the 0 here to be recorded. That would be my uncertain digit here. And this guy would have how many significant figures? Would have 2 significant figures in this case, the uncertain number being the 0 in this particular case. Once again, if you just record 3 in this case, this number would have how many significant figures? Yeah, the uncertain number would be, yeah, the only number present would be 3. So you're basically saying, I think it's 3, but hey, it could be 2 or 4. Once again, if we think about that, that's way worse measurement than we should be able to do on this thing. That's a pretty big area of measurement or uncertainty there, right? So again, we do have to maintain that ability to keep our uncertainty proper to the scale we're using. With 3.0, we're saying I think it's 3.1 maybe as high, or 2.9. That again is reasonable based on the scaling that we see here in terms of how far we could actually take the reading to. Any questions on that one there? All right, so why don't you give this one a go? The scaling's a little off. The numbers go with the big lines next to it to the left. So that's really 9, that's 10, and that's 8. And measure the red line, what it should be properly. See how you're doing. Once again, always first thing you should do is just figure out what everything means. So large markings in this case, I got a 9, I got a 10. So that again is going to give me my 1 centimeter difference between them. We want to count our little markings, which we do have in this case. I kind of drew on it there. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So again, we have 10 little markings between that. That again is going to give us a small scale of it representing basically 0.1 centimeters. So we want to go with our kind of certain numbers. So it looks like it is actually kind of right there on that second little marking there. And since each of those are 0.1, that would be 9.2 would be my certain numbers. Do I need to record anything more than that? I do, again, because on the scale, we could go one more place to the right of that, or if you divide it by 2, gives you plus or minus 0.05 centimeters. We can go to 2 decimal places on this particular scale. So to maintain that properly, we do need to put the 0 here, and that would give us 9.20 centimeters, these being my certain numbers, that being my first uncertain number in this case. And that looks like 3, looks like a winner. And this would have 3 significant figures in this particular case. Any questions on that there? Yeah. It would be considered wrong, especially if the question is probably related to taking a proper measurement. So properly, it would be wrong based on taking the measurement correctly, and it would be wrong sig figs because of that as well. So yeah. Is you always want to give your measurements the proper number of significant figures, and it's hard to say it's always this many or that many because it does depend on the scale you're looking at. So that's why really the first thing that you want to do is whatever you're using in the laboratory, or if you have a question, in the book or whatever, give you some type of scaling, you really want to figure out first off how far you could properly take that reading to. And again, it usually is one more place to the right of that smallest marking. So the smallest marking here is 0.1. We could typically go one more place to the right, which is the second decimal place. If you want to be for sure on that, all you have to do is take the small marking divided by 2, and it'll tell you how far you can take the reading. If it comes to like it does here, 2 decimal places, that's how far you should take it. And you can do that right off the bat. Then even before you take the measurement, really, how far you should be taking the reading to, right? Rather than should I include it or not include it. So if you kind of work that all out at the beginning, like on this particular, I'll spit that out maybe, on this particular piece of equipment, I could take it to 2 decimal places. Having that in your head before you go look at the measurement or a reading will probably help you as well, right? So, rather than I'm just going to look at it and go 9.2 and call it a day, that'll keep reminding you that you do need to take it to the proper number of digits. Other question? Yeah. The large markings are typically the ones that actually have numbers on the scale. So in this case, these guys are considered the large markings. They're also usually called that because they're usually a little bit bigger markings than the other ones. But typically speaking, the large markings should always have numbers associated with them. Usually the smaller markings won't have numbers. And we get that by just simply taking two large markings, just pick any two you want, and just subtract the difference between them. So for example, this is 10, and this next one to the left there is 9. So if I just subtract that, that's 1 centimeter difference, right? So that's pretty much how you get that. And you could do it with even these two if you wanted. That one's 9, the one next to it's 8. Just subtract it, you still get the 1 centimeter as well. So it doesn't matter which ones you grab. Other questions? Got it. All right. So now that we talked about measurements, and really measurements are really where significant figures come from. As we talked about, that's kind of the definition, if you will, of significant figures. It is essentially all those certain numbers in a measurement and that first uncertain number. It's really what makes up how many significant figures you have in a particular measurement. There's actually rules to follow when you're trying to identify, if you're looking at a number, how many significant figures does it have. So let's talk about those rules here, and we'll see some examples in just a second. But the first rule is pretty straightforward and pretty simple. Any non-zero number is always going to be a significant figure. So when we have a number like 4, 2, 6, 3, and mix it up, I didn't do 1, 2, 3, 4 like usual. So we'll go with 4, 2, 6, 3. When we have a number, be it a measurement, we could throw some centimeters down there as well. Now, if we have a number like this, we always want to start counting when we're doing significant figures or trying to figure out how many significant figures there are. We always want to go left to right in the number. And you want to start counting when you hit the very first non-zero. So always left to right, starting to count when you hit the first non-zero. In this case, it's pretty straightforward. That is our first non-zero. So we're going to start counting. So I got one significant figure there, 2, 3, and 4. So this number here would have technically 4 significant figures. So always left to right, start counting always with the very first significant figure or non-zero that you see. Actually is the better way of saying that. Now, when we talk about zeros, these are the ones that sometimes give people a little bit of trouble, and that's because there's kind of 3 different types of zeros that you'll come across. So the first zero is sometimes referred to as a leading zero, and those are not significant. You could have 4 million zeros leading into that first non-zero number. They would none of them would be significant. So if we have 0.0003245, once again, we'll throw some units if we want. Once again, if we look at this number, we're going to go left to right. And again, we're not going to start counting until we hit a non-zero because we know that is going to be a significant figure. So if we go here, that is a 0, not significant, not significant, not significant, not significant. Right there at the 3, that is our very first non-zero going left to right. That is when we start the clock, if you will, and start counting our significant figures. So now if we keep rolling through, that's a non-zero significant, non-zero significant, non-zero significant, and non-zero significant. So this number has 1, 2, 3, 4, 5 significant figures. The zeros are kind of like placeholders, if you will. And again, we don't count them because we haven't hit that very first non-zero yet. Question on that there. I think I might have mentioned it last time, but just a reminder, since we have this number here, when you're writing a decimal like this, you should include that 0 before the decimal when you're writing it so that your numbers just don't run together. So it's very proper just to put that extra 0 before the decimal point so things don't run together. So you should get into the habit to try to do that. So if you have leading zeros, doesn't matter how many you got, they're all not significant. Again, you keep rolling left to right until you hit that first non-zero, then you should start counting. The next type of zero is what is sometimes referred to as a trapped zero, captive zero. These guys are going to be significant. And these are basically zeros that are trapped between two non-zero numbers. So these are zeros that you find yourself looking at that are between two non-zero numbers, and these guys will be significant. So if we look at something like 32004, once again here, we're going to follow our sort of rules. We're going to go left to right. We're going to start counting as soon as we hit the first non-zero, which in this case is right off the bat, right? So we hit it right off the bat. So that is going to be a significant number. The 2 will be significant because it's a non-zero. Now we run into these zeros. So these zeros here are trapped between two non-zero numbers. They're between the 2 and the 4, basically trapped between those non-zero numbers. That is going to make them significant. So this would be significant, this would be significant, and the 4 at the end is a non-zero, so that would also be significant as well. So if we count up what we got going on here, 1, 2, 3, 4, and 5 significant figures. Questions on that one there? All right, that brings us to the last zero, and that is usually the one that does sort of get people a little bit of issues, or gives people a little bit of issues. And these are what are sometimes referred to as a trailing zero. And a trailing zero may or may not be significant. What determines whether or not the zeros that come at the end, these trailing zeros, are significant is if there is a decimal point written in the number, then it will be significant. Again, if there is not a decimal point written in the actual number, you can't imagine it's there. So in some cases, right, we kind of assume it's at the end. It has to be actually written in the number in order for those zeros at the end to be significant. So for example, here, if I had 600 written like this, how many significant figures would it have? It would just have one. We would start counting here. These zeros are at the end. They are not significant because there is absolutely no decimal point written in that number. So this would be one significant figure. If I did this, 600 laid me up a little decimal point right about there, how many significant figures would it have? It would now have 3. This would be significant. These zeros at the end are significant because there is a decimal point actually written in that number, and this would give me 3 significant figures. The decimal point does not need to be anywhere near the zeros at the end. It just needs to be written in the number for it to be significant. So sometimes people think it's got to be like next to those zeros or something like that. It doesn't. It just has to be somewhere in that number. Any questions on there? So that means if I have this crazy measurement like 0.0003200043200 centimeters. Not quite sure how you do that either, but we'll just go with it. How many significant figures does this number have? Should have all the zeros in there, but how many significant figures does it have? What do you think? 12, 11, 11, 8. All right. The answer is I don't know. I was just writing numbers. So let's see. Let's see together here and see what we got. All right. So we're gonna our rules. We're gonna go left to right on this, right? So let's start with this. Is this zero significant? No. How about here? 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 It is. And that's why all those zeros that came before the 3 are not significant, because we have not yet hit the very first non-zero. To answer the question maybe somebody has, which is, aren't those zeros after the decimal point? The answer is yes. But the answer to that question is we haven't started counting yet, because we haven't hit the non-zeros. So even though they're after the decimal point, those zeros, we're not counting our significant figures, because we don't start counting until we hit the very first non-zero. So again, sometimes people go, well, it's after a decimal. Shouldn't those guys kind of be definitely significant? All right, so 3 is really where we start counting in this case. 2 is definitely going to be significant, right? We now have some zeros here, which appear to be trapped between 2 non-zero numbers. So that means those are going to be significant, right? 4 is definitely. Our trade zeros here at the end, are they significant? The answer is yes, because way over here, there is a decimal point. Yeah, so it doesn't have to be near it. What's that? I still lost count, to be honest with you. So let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11 sounds perhaps like a winner there. Yep. Any questions on that? So again, sometimes people, like I said, 2 things are very common mistakes that people make. Like I said, after that decimal point, they see those zeros and they think, well, decimal point, zeros after them, they should be significant. But again, we're not going to count those first zeros until we hit the 3, because we haven't hit it, or non-zero. And then again, sometimes people feel that the decimal point needs to be near those zeros at the end. They do not. Obviously, in this extreme example here, it just needs to be written somewhere in a number. And again, it does need to be written in the number for it to be significant on that there. It does. So in this particular crazy one with the 11 significant figures, what is my uncertain number there? Which zero? The one at the very end. Yeah, the very end zero there, the very last one. This is where my uncertainty, which is why I said, if this is a measurement, you have a pretty darn good equipment to do that. But you're technically saying, I'm good all the way to that very last zero at the end there, how confident I am in my measurement, pretty much. And that's a pretty good confidence there. Good luck finding something like that, probably. But that's what you were saying. Now, if we look at our 600 down here, right? If this was, say, centimeters and a measurement or whatever it may be, my uncertain number in this case is which number? Got quiet. I'm going to take a drink of water. What do you think? What number is my uncertain number? I think I heard somebody say 0, and I think I heard somebody say 6. And between those 2 numbers, we covered all the numbers that are there. So one of those should be right, I hope. All right, let's just start off backwards here, which is, how many significant figures does this number have, the way I wrote it? It has 1 significant figure, yeah? And that's because this is significant. These zeros are not, because there's no decimal point written, correct? Which means significant figures is all the certain numbers plus the first uncertain number, which means in this case, since we only have 1 significant figure, maybe. Did it just die? Oh, it's back. All right. It was a dramatic pause, apparently, on the screen there. Like, wow. All right. So because this has 1 significant figure, I feel like it doesn't like that move right there. Maybe. There we go. I feel like I'm going to get through the sentence, maybe. If it has 1 significant figure, the 6 is both the certain number and also the uncertain number. So our estimation would be actually that digit right there. So if you remember last time we were talking, I said that it's not always the last digit that's written, the estimated digit or uncertain digit. But it should always be the last significant figure that you have. So in the case of the 600, the last significant figure I have is 6. And that means that that's also my uncertain number in this particular case. Just like down here, my 600 with the decimal, the uncertain number is the 0 at the end, because that would be where the uncertainty lies in that measurement. So sometimes, again, people, when they're asked that question, sometimes the lab likes to ask that question, like a post-lab type question, like, here's a number, which one's the estimated digit or uncertain digit? And I think they've changed it, but years ago, she used to use 12,000. 12,000, which one's the estimated digit? It is the 2. Yeah, and that's because no decimal is written there, and the only significant figures we have are these 2, right? These are trailing zeros, no decimal, and that means it's actually the 2 is my estimated digit in this case. Again, not always the last number, but always the last significant figure that's written is the estimated digit. I would say 9 times out of 10, it is kind of the last number in a lot of cases, but not always. But most of the time it will be, but it should always, the way you want to think about it is the last significant figure is where the estimation will lie. Like if it was like 602, is that what you're asking? Are you asking like how many significant figures it would be, or the uncertain digit? So you tell me, how many significant figures does that number have? Which one should be the uncertain number or estimated digit? It is the 2, yeah.
If you wanted to do like, it might be around 605 or 595.
Yeah, that's basically what this is. So when you have the number like this here, see if I can get a page turn here. So when you have like the number written like this, right? It basically has 3 significant figures. And basically what you're saying is the uncertain number is right there, which means what you're really saying when you take that measurement is, I think it's 600, but this one actually means it's about 599 maybe, or maybe it's 601. It's somewhere in that range, but I'm looking at it and I feel it's this. But the uncertainty lies here, and that's basically what you're saying when you record that measurement, which would be the proper measurement, the one in the middle. You don't always have to record the range or anything like that, but that's basically what you're saying based on the significant figures in your measurement is, okay, I think it's the middle one, 600 with the decimal, which has 3 significant figures. And what I'm saying is, based on the scale that I took that reading, I think it's 600, but we're not really sure about that last digit. And because it's 600, it might mean that it's like 599, or it might be it's 601, a little bit more, a little bit less, but it's somewhere within this last digit here where it's going to be correctly, right? And that's where the uncertainty is. I may look at it and think it's right on the nose. You may look at it and go, I think it's a little less, right? And stuff like that. So that's where the error comes in. And that's different, for example, and why it's important to record the proper number of significant figures, because if you recorded this as, say, your measurement, as we just talked about, the uncertain number is here, right? Which is 1 significant figure. And what you're saying in this case, when you record this down with whatever units it may be, school called them centimeters in both cases, what you're saying when you record it like that is, I threw a dart at the board and based on my scale, I got 600. But, you know, based on the scale that I have, it might be as much as 700, and it might be as little as like 500, as that is where the uncertainty lies. And that's a pretty big range, right? Which is when we take measurements, we don't want that much uncertainty usually, right? This is also why, for example, if you're measuring out like a liquid, you wouldn't grab a beaker, because a beaker has got like a few markings on it at best. And if you're like here, I'm like, I don't know, it's somewhere between like 40 and 50. So maybe it's like 30 or something like that, or 40 or 45. I'm not really sure exactly where it's at. But if you took something like a graduated cylinder, where there's a lot of markings on it, right? You're going to be able to measure out that volume a lot better based on the scaling there. You're going to be able to really dial it into what you're looking for in terms of a volume, rather than, I don't know, I don't really got a lot to work with here. So there's a lot more uncertainty, say, in a beaker versus a graduated cylinder. That's why a beaker is a really bad piece of equipment to use to take volume measurements, besides the fact that it's really big on the top and the meniscus gets really spread out and you can't really take a very good reading. A graduated cylinder is much better. It has a lot more markings. You could get a much more accurate sort of reading of your volume, or if you're measuring out a volume, you can measure out a lot better than you could with something like a beaker. So, good. Other questions? Okay. Now, speaking of significant figures, we talked about scientific notation and we talked about it as well. Remember again, when you have scientific notation written, it is written in this sort of form, n times 10 to the n. All the numbers before the times 10 part are always going to be significant. So if we had a number written as 1.2 times 10 to the 3, this guy would have 3 significant figures. So all the numbers that come before the times 10 part. That is why, again, if you write a number in scientific notation and you're trying to write a number to the proper number of significant figures, sometimes the only way you could get it to the right number of significant figures is to actually use scientific notation. So for example, let's say I didn't need 3 significant figures, but I needed 2. I could just write this like this, 1.2 times 10 to the 3. This has now 2 significant figures. If I needed 1 significant figure, I could write 1 times 10 to the 3. I now have 1 significant figure. So when you have a number that's written in scientific notation, all the numbers before the times 10 part are going to be significant. And you should analyze that before you, if you make it into a regular number, a decimal type number, it is how it is written in scientific notation. What I mean by that, for example, let's just say I had 1.2 times 10 to the 4, for example. So what a lot of people will do is, okay, 1.2 times 10 to the 4, I'm going to punch that into my calculator. And basically what it's going to tell you is we're going to go 1, 2, 3, 4 places to the right, add some zeros. And we'll end up maybe something like this, 12,000. And now they'll look at it and go, oh, that's like 5 numbers, so it has 5 significant figures. And that would be incorrect, yes? And that is because you look here, this has actually 2 significant figures, right? And by the way I wrote it, did it have 5 significant figures? Did not. It only has 2, which is the right way. Yeah. So, but sometimes what people do is they kind of turn their number from scientific notation to just like a regular number. They go and they start adding some zeros and they start counting those zeros. And before you know it, it's got like 400 significant figures. So when the thing is written in scientific notation, that is when you want to sort of assign, if you will, how many significant figures it has based on how it's written. It's very simple. It's just how many it has before it. Now, as I mentioned before, there may be only one way to get a number to the proper number of significant figures is to write it in scientific notation. So if we take our 12,000 that we have there as an example, and let's just say I needed 3 significant figures for an answer. Bless you. There is no possible way to get this number in decimal form, if you will, a regular number form, to have 3 significant figures. The only way maybe you're thinking in your head is I could write 120, right? That is 3 significant figures. That is 3 significant figures, but there's a very big difference, yes, between those 2 numbers. And if you're not sure, let me just give you a classic example that everybody will understand. If I owed you $12,000 and I said, here, I'm going to pay you 3 significant figures, here's 120 bucks. You're probably not going to be very happy with me, right? So there's a very big difference in terms of the meaning of those 2 numbers. So although you did get the right significant figures, you change what that number means. That happens a lot in rounding because people, rightfully so, want to get the answer to the right number of significant figures. They do kind of extreme rounding, right? Just to get the right sig figs and change the meaning of the number. So you never want to change the meaning of the number. But so the only really way I could do that is really what I did right here, I think. So we could go 1, 2, 3, 4 almost. 1.20 times 10 to the 4th. And that is going to give me now 3 significant figures here. By the way, when you go from scientific notation to decimal form or decimal form to scientific notation, you should try to maintain the proper number of significant figures. That is why, for example, if we had something like this, 00400, and I wanted to write this in scientific notation, how many significant figures does this number have? It does have 3. We're not going to count any of these. These are all leading. This is where we start counting. These zeros at the end are going to be significant because there is a decimal point written in this number. That means when I go to turn this into scientific notation, 4.00 times 10 to the 1, 2, 3 minus 3, I need those zeros to stay because now it has 3 significant figures in scientific notation, 3 significant figures in decimal form where it started. If I wrote it like this, 4 times 10 to the minus 3, how many significant figures would it have? 1. I lost a couple along the way. As we've been talking, that's not a good thing, right? To lose significant figures. So you should never lose significant figures as you're kind of just going back and forth from regular number to sort of decimal. That's also why, for example, if we did have this, actually we'll do this, if we had 12,000, all we want to do is just write it in scientific notation. We would go 1, 2, 3, 4, and we would write it 1.2 times 10 to the 4th. Here it has 2 significant figures. We would maintain the 2 significant figures here as well. Any questions on that there? Okay, let's take a look here, maybe at some. There's our rules as we just talked about it. So let's take a look at some of these examples. As we talked about there, again, all non-zeros are going to be significant, so always left to right. So in this case, starting here, 1, 2, 3, 4 significant figures. All of them are significant. Starting here, 1, 2. Starting here, 1, 2, 3. And 1, 2, 3, 4, 5, all going to be significant left to right here. Here, looking at this, we have our zeros that are trapped, so significant. These zeros will be significant, and one more makes 4. The 2 is significant, the 0 is significant because it's trapped, and the 1 is significant at the end, which would give us 3. In the case of the next one, we shouldn't start counting until we get to the 7, right? So that is our very first significant figure. That is a trap 0 and also a non-zero, so that's going to give us our 3. And here we want to start counting until the 4. That would be our very first non-zero. Trapped, non-zero, trapped, non-zero, giving us 5. And again, our decimals here, once again, 200 minutes. No decimal written. That would be our only significant figure, and also where the uncertain number would lie. So that 2 would be our uncertain our estimated digit. This would be significant. All these zeros now at the end are significant because there is a decimal point there. So that would be 4 significant figures on that. And here, a couple more zeros at the end. We're not going to start counting here until we hit that 4. So that's the very first number we're going to start counting. The 4 next is going to be significant, and the 0 at the end will be significant because there is a decimal point there. Here, we're not counting until we hit this 2. And the 2 next to it would be significant, which would give us our 2 significant figures. And here we're not counting until the 3, and we're out of numbers at that point. So that would be our 1 significant figure there. Any questions on that stuff there? And again here, no decimals, not going to count. So 2 significant figures, those zeros don't count at the end as there's no decimal. 2 significant figures, 3 significant figures. So for the first one up there, which one is the estimated digit? It is the first 4 or the second 4? It is the second 4. Next one, it is the 1. And the last one, it is the 5. Again, none of those are the last digit written, but they are all the last significant figure that is present is where the estimated digit will be. Question on that. And as we just did in scientific notation, again, before we move it, just simply before the times. So that's 3. 2, and a bunch, 5 there as we go there. And again, as we talked about, we do want to maintain the Cropper's number of significant figures. So in this case, we would go 1, 2 places to the left. Because that decimal is there, that means that these zeros at the end are significant. So we do need to carry them over to our scientific notation. Here, there is no decimal written. We still assume it's here, 1, 2, 3, 4, 5. But we do not carry those zeros over here because they're technically not significant in that first one, even though that's sort of where we assume the decimal is at, but it's not written, so they're not significant. So one significant figure on both of those. And here, both of those significant, just going one more place over, 3 times 10 to the minus 1. Any questions on that there? All right, so take a second here. Identify the significant and non-significant zeros in each of the following numbers and write them in scientific notation properly. Okay, so let's take a look, see how you're doing. We'll start with the first one. Let's start with how many significant figures are there in that first one? There are 4, and again, we want to start counting to the 2, and then everything past there is going to be significant. So now we want to remember scientific notation, a number between 1 and 10. So we got to go 1, 2, 3 places over. That's going to give us 2.650 times 10 to the negative 3, as it's a small number, 1, 2, 3. And again, we do need all those numbers there, as these guys are significant. These guys are not significant there in the front end of it. Any questions about there? Next number has how many significant figures? Yeah, it does have 5. All of them are significant. We're going to count here. Everybody's significant. The 0 there is going to be significant because it's between 2 non-zero numbers. In this case, we just need to go one place to the left, actually. So 4.3026 times 10 to the 1 here, grams. And again, we do need to keep all those numbers because we do not want to lose any significant figures as we just write a number in scientific notation. Again, we don't want to lose anything along the way. Last one, how many significant figures? It is 4. We start counting here all the way through here. These zeros are not going to be significant because they're at the end and there is no decimal point written. We will assume that the decimal is here for the sake of scientific notation, 1, 2, 3, 4, 5, and 6. So 1.044 times 10 to the 6 liters. Again, we don't want to put the other zeros there at the end. Otherwise, we have way too many significant figures than we should have. Any questions on that one there? Yeah. Yes. Like for the second one, is that what we're talking about? Yeah, you do need to put the 1 there. This one here, I'm assuming we're talking about. Yeah, you do need to put it there. Yeah. So on that particular, it's one of the few places that we actually do put 1s in chemistry. So on that, you do need to put actually the 1. Yeah. Other questions? Any questions so far on what we've been talking about? All right. So we did that basically. Now, we've been talking a lot about measurements and really what are sometimes referred to as measured numbers. And they do come from obviously a measurement. They have a certain number of significant figures based on the measurement that you take. Another type of numbers are what are referred to as exact numbers. And exact numbers basically come about one of 2 ways. They are either a definition, and by definition is something like this, like 1 foot is exactly 12 inches. 1 inch is 2.54 centimeters exactly. These are definitions. They're also what are sometimes referred to as equalities. And these are exact numbers. The other way that we sort of get an exact number is something that is counted. So we'll use the baseball example up there since spring training starts in 3 weeks. We have a couple of baseballs on the desk. We're not going to do any type of, measurement to figure out how many we have. We're just going to simply count how many baseballs we have, right? The classic textbook example is a basket of apples. You're just going to count how many apples you have. So the deal with exact numbers is this. Exact numbers technically could have as many significant figures as you want because they're exact numbers. So you can have as many significant figures as you want. What that means is, and really where it will come into play is what we'll talk about here in just a bit. When we're doing calculations and we want to give our answer to the proper number of, say, significant figures at the end of the calculation, what we want to look at really is measured numbers, things that have proper significant figures. We really ignore exact numbers in calculations because I may say it has 5 sig figs, you may say it has 6, and because it could have as many as you want, you could use as many as you want. So to sort of take that out of calculations, when you come across something that's an exact number, you don't have to worry about it in terms of your calculation. Now, we'll talk more about it a little bit later, but if you remember, we have kind of our English units and we have our metric units. And definitely, if you are using an English to English conversion like this, feet to inches, it is definitely going to be an exact number. If you're using a metric to metric conversion, like this guy underneath it, metric to metric, that is definitely going to be an exact number. You don't have to worry about it in your calculation. It is only, as we will talk about, when you cross over from English to metric and you're doing some type of calculation that involves that type of conversion, you actually do need to take them into consideration when you're doing a calculation. And again, we'll talk about that in just a second. But typically speaking, if it's a straight metric to metric or English to English conversion, it's going to be considered an exact number. And if it's something that's counted, it'll be considered an exact number. The good news is you pretty much can just ignore them in terms of significant figures for your answer. You don't have to worry about how many they have. So here again are some examples of that. All these are exact numbers. Again, you have a metric to metric conversions all through there. Each of those are exacts, US or English to English. And again, things that are counted would be considered exact numbers. So for example, here, if we have 3 coins, that's probably going to be a exact number, right? If the diameter of a circle is 7.902 centimeters, that's going to be a measured. And 1 hour has 60 minutes, and that would be a definition or an exact number in each of those cases. So exact number, measured number really, and an exact number definition. So for each of these, how many significant figures does the first one have? 2, right? Next one has 4. Next one has 1, which is just this one, right? And last one it does have 3. All of those are going to be significant. Decimal point, that guy's going to be significant at the end. Any questions on that one there? All right, so take a moment here to do this one. Which answer contains 3 sig figs? Which one has all the zeros are significant? And the last one, how many significant figures in that one? So take a moment for each of those and see what you come up. Okay, so let's take a look at the first one. We're looking for 3 significant figures. So let's start with the first answer. How many does this first one have? This first number has 4, right? The second one has 3, which I think is what the 2 was set for. So that has 3 significant figures there. And this one here has, at the end, does have 4 significant figures, right? So number 2 there does have 3 significant figures. Again, we wouldn't start counting until we hit the 4 in that particular case. And the 7 and the 6 there are going to be significant. We're looking for in B where all the zeros are significant. So are all the zeros in this number significant? They're not, because we really don't start counting until the 3, which eliminates the ones that came before it. How about here? Are all these zeros significant? They are, yes. How about here? That it is 2050, but it is currently written in what form? And when we have something written in scientific notation, where do we find our significant figures? Before the times 10 part, before we convert it into a regular number, right? So in this case, it actually has 4 significant figures, and all those zeros would actually be significant in this case. So actually, both of those there would be a winner on this particular one. Yeah. You don't. The 10 is just basically how far you're going to move the decimal place and stuff like that. So when we're talking about the number, this is truly the number. And then the 10 just tells us, if we need to add some more zeros or something, if we convert it out. Yeah. Other questions? All right. The number of significant figures here in 5.8 times 10 to 2, that would be 3. Again, ready written in scientific notation. So that is what we want to look at. And it would have 3. Any questions on those there? All right. So now that, yeah, I'm sorry. Yeah. The truthful answer is probably not. And then like a multiple choice, not on purpose. How's that? Not on purpose, I think, unless it says, unless it's a question that clearly says like pick all that apply or something like that, then it might be more than one. Online, there might be questions like that where, maybe there is, more than one right answer. Hopefully it will tell you. It usually will say something like that, like pick all that applies or something like that, or pick all the correct answers or something like that. Usually for our exams, and that's usually where you'll find the multiple choice type questions. It will be more one, pick the best answer out of it. One best answer, yeah. Other questions? All right, so now that we know measurements, what significant figures are, how to count significant figures, let us talk about significant figures and calculations and how to do significant figures and calculations. So when we do give an answer, we do want to make sure that we always end up with the right significant figures for our answer. Our calculator will not do several things, including always give you the right number of digits or significant figures for your answer. It also will not put things in scientific notation sometimes for you. It will put it in as well. So just remember that when you see a number on your calculator, that might not be the correct number in terms of what you should give for your answer. So let's talk about what we should give for our answer. And before we do that, let's talk about also a really important thing that we talked about before, which is rounding. So when we round, normal sort of rounding rules apply. And that is basically wherever you want to round, you look at the next number. And if you look at the next number and it's less than 5, we typically will drop all those numbers at that point. If the next number to where you want to round is more than 5, we usually round up. So usually less than 5, we drop. And more than 5, we round up. And again, looking at wherever our answer should end, the next number over is really what we want to look at when we do that. We do not want to do any kind of crazy rounding like we were just talking about, right? So once again, 13,333, and I want, 2 significant figures. What should the answer be? $13. Any others? How about 13,000? Let's start with the one down here. How many significant figures does this have? 2. That's good. How about here? How many significant figures does that have? So we got that part right? So is this number here the same as that number? Again, if you go back to the example I did earlier, if I owed you $13,333 and I said, here's 2 significant figures, here's $13, not going to be very happy with me, I imagine. That's a very big difference in meaning. So once again, although that again is the correct number of significant figures, we do not want to change the meaning of that number. So we got to maintain the meaning of the number. This still has 2 significant figures. It is roughly the same meaning. maybe I get like a $333 teacher discount, right? I'm a good guy, right? And I give you $13,000 and I owed you $13,333. You might be somewhat okay with that in that type of situation. By the way, we also could write it how? We could also write it in scientific notation times 10 to the 1, 2, 3, 4. Also has two significant figures and maintains the meaning of the numbers. So once again, we do want to round. And what happens a lot again is people are trying to get that right number of significant figures in their answer, and they go a little extreme on the rounding. So round properly, don't go crazy with it. And you should hopefully be okay, I hope, right? So again here, if we were going to take this number and we wanted two significant figures or three significant figures would be here. We would look at the 3 and we would just drop the rest of the numbers. If we wanted two significant figures, it would be the 4, and we would also drop the rest of the numbers because the number next to 4 is 2, it's less than 5. Here, if we wanted three significant figures, it would be here. We would look at the 8, we would need to round up to 14.8. If we wanted only 2, it would be here to the 4. We would look at the next number over, which is the 7, also above 5, need to round up to 15. And same thing here. If we want three significant figures, we would go here. Here we would need to round up. And why should I not write 326? Is there a difference between the meaning of 326 and 3,256? There is, right? Again, although I do have perhaps the right number of digits, I have now significant figures. I have now changed the meaning of the number. Here, we would not just drop everything. We do have to put the 0 there to maintain the meaning of the number. Should I put a decimal after that 0? I should not, because if I put a decimal after 0, how many significant figures would I have? I would have 4 in that case, right? So again, you want to be careful not to go too far one way or the other, put too many significant figures in, but you still got to make sure you don't change the mean number. Once again, here, if we want two significant figures, that is going to be the 2 in this case. We would look at the 5 and need to round up. Same deal here. We do not write 33 because although it is two significant figures, very big difference between 33 and 3,200, basically. We can lay up just a couple of zeros, right? And no decimal, because that will still be two significant figures. We could also do a little scientific notation times 10 to the 1, 2, 3. Why did I not put the zeros here in scientific notation when I wrote it? If I put the 2 zeros in scientific notation, how many significant figures would I have? I would then have 4, right? And which would be too many in this particular example, since we're only going for 2 over here. So if I wrote 3.300 times 10 to the 3, that would now have 4 significant figures, too many for shooting for 2 significant figures here. So again, you just want to be careful of these things and not be focused so much on one thing that you kind of mess up some other part of the number. So you get one thing right, but the other part of it's wrong in terms of the meaning. All right, write the correct value here. Okay, so let's take a look. We're going to start with the same number in each case. First case, we want 3 significant figures. So going left to right, that is going to be my third significant figure there, which is the 4. In this case, we want to look at the number next to it, which is a 5. So we do want to round up in this case. And that would then get us here 3.15 grams, which is our 3 significant figures. Question on that one there. Starting again with the same number, we want to go only to 2. That's going to bring us to the 1 as our second significant figure. Looking up the 4, in this case, it's less than 5. We are going to drop it, and we will end up with 3.1 grams. Why do I not write 3.1 and just keep the zeros in this case? Yeah, so now it's got 4 significant figures, right? Too many for what we're looking for. So again, these are things we want to think about and not just go, it looks more scientific or chemistry like to put some extra zeros in, right? So we want to make sure we do end up where we are looking for in terms of our answer. Any questions on that? Cop. All right. The number next to it, which is above 5, so we're going to do a little rounding up, and that should be an 825 centimeters in this case. Yeah. Question on that one. Next, third significant figure right there at the 2. Next number is a 4. So in this case, we are going to drop it. And again, the reason we need to drop it is because if we keep them as zeros, we're adding more significant figures than we need in this particular case. So we got to just drop them in this particular case. And in this case here, we're looking for the third significant figure. Where is that? Right about there is the third significant figure. It's not there, right? So in this case, we actually need to add in the third significant figure in this case. And that's again a case where we need to add a 0 to get to the right number of significant figures, and it would be significant. Any questions on that there? All right, then let's talk about now actual calculations and what you should do. So really there's kind of two sets of math operations as you typically will do. First one is we oftentimes will multiply or divide. So in a situation where we're multiplying or dividing, we want to give our answer to the proper number of significant figures. So the answer that you should have when you do either of those things, multiply or divide, your answer should have the same number of significant figures as the number with the least number of significant figures. So if you multiply or divide, what you're looking for is significant figures. You're looking for whatever number in that calculation of multiplying or dividing has the least number of significant figures, and your answer should reflect that. So for example, if I took 0.0432 and I times it by 146, in this case, let me do that, 0.0432 times 146. We got 6.3072. This is what my calculator spits out to me. Remember, again, the calculator may not always give you the proper answer in terms of significant figures. Because we are multiplying here, we are looking at significant figures. So we want to analyze the numbers in our calculation. So let's start with this number. How many significant figures are in that number? It is 4. Starting counting here all the way through to that 0, which is significant because there's a decimal. Significant figures in this number, 3. The one with the least number of significant figures is 3. My answer should have 3 significant figures. So again, we look at our number on our calculator. Third significant figure takes me to the 0. I'm going to look at the 7. I'm going to round up in this case, and we should actually end up with a 6.31. Yeah. Question on that one there. Now, if I had 42.30 divided by 0.44326, give the answer to the proper number of digits. I'll do it. Okay, so we punch this into our calculator. On our calculator, we have this display 95.429319114. Just a general reference. Don't ever give an answer with that many digits. Yes, that's too many. So always make sure you try to get the right sequence. I say that because I've had people like write numbers and then they like continued on the other page, or they wrapped around the page. It just kept going. All right, so this is what our calculator gives us. Here we are dividing, so either multiplying or dividing. We're going to look at significant figures. So top number has how many sig figs? Has 4 sig figs. Once again, this 0 is going to be significant because of the decimal point. Bottom number has 5. Answer should have 4. Yeah. That's going to bring us to the 2 here. looking here, that is a 9, which means we do need to round up, and we should end up at 95.43 as our answer there in terms of proper number of significant figures. So again, if you multiply or divide, it is the significant figures, and it is the one with the least number of significant figures is what your answer basically should look like. It should have that many significant figures. Any questions on that there? Now, what are the other two things that we typically do? That is our friend, a little adding and subtracting, right? So if you add or subtract, we actually look at decimal places. And we do not look at significant figures, but we're going to look at decimal places. And your answer should have the same number of decimal figures. It is really the least number of decimal places. And both of these cases, it's because it is really your worst measurement, essentially. Yeah. So what's that old saying? You're only as good as your weakest link. So your worst measurement in a calculation is as good as you could do in terms of your actual calculation. Your overall sort of calculation there is based on really your worst number that you have, either decimal wise or significant figure wise. So if I had 32.111 plus 7.22 plus 6.3. And it's late, so I'm going to use the calculator here. It's been a while. It's been a long day. I got that. And we'll go with that. And on our calculator, if we punch that in, we got a little 45.631 action happening there. I think, maybe. And in this case, we want to look at decimal places since we are adding. So first number here has 3 decimal places. Again, not significant figures, but decimal places. This number has 2 decimal places. This number has 1 decimal place. That means my answer should actually go to 1 decimal place, which is there. So again, we want to round properly. And in this case, we look to the number to the right, which is a 3. We're just going to drop it in this case, gives us 45.6. 45.6 has 1 decimal place. How many significant figures does it have? It does have 3, and that's really important. It has 3 sig figs, but has 1 decimal place. That's important because if I took this number and then went and multiplied it or divided it, I need to now look at significant figures, right? So it's important to remember that if you add or subtract, you're looking at decimal places, but then you might take that number off and multiply or divide, then you need to switch over to significant figures. So I'm going to give you kind of the general rule that you should follow in general when you're doing calculations. So, and it's a really good question. So my personal thought on it is this, that if you're going to do any type of calculation, regardless if it's like addition first or subtraction, multiplying or dividing, and you're going to get a number, and then you're going to take this number and then take it and do another calculation with it. And maybe even you get another number after you do that calculation. You're going to take that number and do another calculation or step in a calculation along the way. The general rule is you really should avoid rounding to the very end, because every time you round a little bit after you get the number, you're actually moving yourself away from the right answer. And then you round again after the next step, you're moving a little away. And you may actually find yourself very far away from the correct answer. So the general rule, which I think is your question, is you really want to kind of avoid rounding too much until the very end. But with that being said, you definitely should keep track of all the calculations you did, so that when you get to the end, you can then clean it up to the proper sort of number that you should end with. So if you did like addition to begin with, and then you did multiplication, you really at the end, when you were going to kind of clean up your answer, you need to go back to like the first step that you did and figure out, okay, I did this where I should be looking at decimal places. And that may give me 1 decimal place, which gives me 2 sig figs. Then I just took it and multiplied 2 sig figs by 3 sig figs. That should give me 2 sig figs for that answer. Maybe I added it at the end. And so you want to keep track of it all the way through so that you could kind of clean it up at the end. With that being said, if it's like a straight sig fig type calculation, maybe like this is just, in this chapter per se, you may see people around a little bit more than maybe they should. To be honest with you, when I do calculations over multiple steps, I just continue to roll with the number that's in my calculator, to be honest with you. And the safe thing to do is if you're doing that where you're going to get an answer and going to continue on, is just to keep a couple of extra digits. They're sometimes referred to as guard digits. Just keep, if you need to write the number down and it's a big number, you don't necessarily have to write every number you have there, but figure out, okay, if I were going to stop the calculation, let's just say we had, actually the number here, let's just say we had this number in our calculator and we know we're going to take this number that we saw and we're going to continue on with it in another calculation. So what I would do is go, okay, well, I don't really want to round. I'm just going to keep the whole number in my calculator. But, I know if I were to stop at this point, that's where I should lay it up. That's really where it should be rounded. So either I can make a mark like that, I could keep a couple of extra digits, even 3 is okay, and just continue on with those extra digits, but keeping track of where it should stop. And that usually will prevent you from hitting those kind of rounding errors or like, again, every time you kind of round, you kind of move yourself away from the right answer. So that's one way to do it. Sometimes people put a little line above it just to kind of keep track of where things should end up. And at the end, you really do want to kind of clean it up. Also, with that being said, if you're doing multiple steps together, you do have to keep track of what you're doing. So for example, why don't you do this one? Let's say we had 32.4 times 12 divided by 0.46328. What should the answer be? Why don't you also do this one? Let's say we're doing 62.5 divided by 0.2468. I'll throw an 8 in there maybe. And then what I want to do is subtract. Let's subtract 4.333 from it. All right, so go through all the steps, keep track of everything, maybe try not to round to the end, and see what you come up with in each of these cases. So obviously we're comboing a bunch of stuff here together. Got on top there, so I'm going to take 32.4, going to multiply that by 12. By the way, on your calculator, I would hit equals. Then I'm going to divide it by the number on the bottom, divide by 0.46328. And if I could hit that equal sign, maybe, there we go. So in this case, on our calculator, we will end up with a bunch of digits, which as we hopefully know by now, probably not the right answer digits. So on our calculator screen, we've got 839.233293. And now we got to figure out where we should give basically our answer to. So when we do this type of math, right, when there's multiple steps, especially something like this, typically speaking, we do what's in the parentheses first, right? So we are multiplying, which means we want to look at significant figures or decimal places. Which one should we look at? Yeah, we're looking for the least. So first number has 3 significant figures. Next number has 2. So technically speaking, when we get the answer for the top, which if we just did the top part would be, and again, this is just the top part here, I believe, we will get a number like this. And technically speaking, this should end up with 2 significant figures, right? Right about there is about where it should end up on the top part. We're now going to technically at this point take our answer, which should have 2 significant figures from the top part of the calculation, and we're going to divide it by the number on the bottom, right? So now we're dividing. So we moved from multiplication to division. Good news is here we're still looking at significant figures, right? So the bottom number has how many significant figures? 5 significant figures. They're all significant starting here and above, right? So ultimately, the last calculation we did was division, which is dividing 2 significant figures by 5 significant figures. That means my answer should have how many? Should have 2 significant figures, which actually brings me to this guy, right? Now I need to look to the guy to the right, which is a 9, and it should round up 840 decimal or no decimal. I saw shaking heads, so I'm gonna go with a no on that shaking head. So no decimal on that. Also 84 okay in this case? No, because again, big difference between 84 and 840, different meaning in this case. Now, this is sort of, I think, your question as well. Personally, I would roll with the 388.8 in my calculator and continue on. If you did round, just to show you, you do get a little bit off of really probably what the right number would be. Technically speaking, the top number would be 390, right? If we took it to 2 significant figures, we then would be taking 390 divided by 0.46328. So in this particular case, if you did kind of strict rounding, bless you, before you got to the end, you would end up with 841.8235193 on your calculator. We would still go to 2 significant figures, and you would end up at 840. So in this case, you actually will be okay. It will actually come out the same. But the general rule is you really don't want to round too much until the very end. Again, you could probably just keep all those digits and continue on with the calculation in this particular case. Any questions on that there? Now let's take a look at the bottom one here. We're also doing a couple different operations. We are dividing first, which is probably what you would do first. So we're going to divide that. And in this case, you're going to take 62.5 divided by 0.2468. On my calculator, I'm going to get 253.2414911, which technically I'm now going to subtract from this number, right? Is what we're going to do next, right? And if I subtract that number, just rolling with the whole number in my calculator, I will end up on my calculator now as 248.9084.911. Once again, do not give that many digits as your answer. I know for sure that's probably not right. Yeah. All right, so now we want to kind of think about what we should do or where we should end up. So we got to take it part by part. We got to our end answer, which is good. But now we got to go back through our different parts of our calculations and keep track of what we were doing. Very first thing we did there is dividing. Am I looking at significant figures or decimal places? Sig figs. Top number has how many sig figs? 3. Bottom number has 4. Answer technically from just that part of the calculation should have how many significant figures? 3, which puts me right about there. That's about a 253 technically, right? Technically, this answer, if we laid up right there, is 253, right? That's important because the next thing I'm technically doing is subtraction, which means I should look at significant figures or decimal places. Yeah. So this guy has how many decimal places? Guy has no decimal places, right? There is no decimal place written, right? So there's no decimal places written there. This one has 3. That means technically how many decimal places should my answer have? Should have no decimal places, right? No decimal places is the least number, right? So if you have 0, that's the least. That means we actually should end up right about here, whole number. That means we need to look at the 9. That's a 249 is probably where that should end up. Once again, if you did sort of clean this guy up right off the bat, you would have took 253 minus 4.333. And you would have ended up with, if you did this, let's go up here, you would end up with 248.667 on your calculator. And once again, we would actually go to our whole number, and looky there, we will get, in these kind of simple examples, we will get kind of the same answer. But in really I'll say real problems outside significant figures when you're doing a bunch of calculations and using those answers, you really should try to avoid rounding to the end. But as we did in these examples here, once you get to that last answer, you do need to go back through all your steps and think about, okay, is this like significant figures or decimal places? How far should that number go? And then figure out where that answer should go based on the next step and how far the next answer should go. And ultimately, the end result of where you should end up in terms of your calculation is really based on the very last step. But in order to evaluate the last calculation step that you did correctly, you have to know correctly all the previous calculations you did and how far those numbers should go to. So like we talked about earlier, we had one decimal place in that answer, but it was 3 significant figures, which would be important if I then took it and multiplied. So although really what determines where you end up with your answer is the very last step, in order to get to the last step correctly and look at it, you got to know correctly where you should take everybody in all the previous calculation steps. Any questions on that there?